Welcome to this video on chi-square test for independence. By the end of this video, you should be able to perform a chi-square test for independence and choose the appropriate chi-square test in a given setting. Alright, so we previously collected data on whether you could taco tongue or evil eyebrow. And so what I have here is a random sample of 600 seniors collecting the same data, whether they can taco tongue or evil eyebrow or do both. Do we have convincing evidence that the ability to do the taco tongue and the evil eyebrow are associated for all seniors? Okay, so the word associated here is a clue in that we want to do this chi-squared test for independence. So what does it mean to be independent? We've talked about this previously. Being independent is knowing whether or not one event has occurred does not change the probability of the other event. In other words, the overall probability is the same as the conditional probability. So kind of a throwback to our probability days. So we're saying the probability of A, that's the overall probability, is the same as the probability of A given that B has already occurred, or the probability of A given that the complement of B has occurred. Okay, so your conditional probability is the same as your overall probability. It's kind of a good way to look at it. So these were the observations of the 600 seniors. I want you to take a moment to fill out this table of our expected counts. So quick review, remember your expected count is your row total times your column total divided by your table total. Okay, so take a moment, pause the video, come back when you're done. All right, so here's our expected counts, 160, 40, 320, and 80. Now, the question that comes to us next is, do the data provide significant evidence that there's an association between the ability to taco tongue and evil eyebrow for all seniors use alpha 0.05? Okay, so for the chi-squared test for independence, we're really looking for that association or whether they're independent of each other. So to state the hypotheses, our null hypothesis is going to be taco tongue and evil eyebrow are not associated for all seniors. And so what this statement is saying is that they're independent of each other. Okay, so our null hypothesis is that the two are independent from each other. Okay, so our alternative is taco tongue and evil eyebrow are associated for all seniors. Okay, and so that means that they're not independent. Okay, so we're going to perform our chi-square test for independence. So performing this test looks a lot like we're doing the chi-square for homogeneity that we spoke of previously. Mathematically, they're calculated the same. The difference is where is the data coming from. The chi-squared homogeneity is 2 or more samples but only one variable, while your chi-squared independence is 1 sample and 2 variables. So we have 1 sample of 600 seniors and we have 2 variables of whether they can evil eyebrow or not and whether or not they can taco tongue. Okay, so that's the big difference, but mathematically they're going to come across the same. So our conditions, we have random, and it does say a random sample of 600 seniors. All right, but you got to be specific and call out why you know that. Then we have our 10%. And 600, which is our sample size, is less than 1/10 of all seniors, because that's how it calls out the population in the problem. And then our expected counts. So normally you won't have done this table previously at this point, so I'm going to show you kind of how I want you to write it. Write it like you're writing your matrice with your expected counts in it. And then we're going to say the whole thing is greater than or equal to 5. Okay, so the reason we do that is so the sampling distribution is approximately chi-squared. So we're saying the shape is going to be that skewed right, so we can use the probabilities from the chi-squared table. Remember, we check our 10%, so sampling without replacement is okay. All right, and then the random is so we can generalize to the pop. If we were doing an experiment and we did random assignment, it's so we could show causation. All right, so what I want you to do here is I want you to pause the video and I want you to do your whole setup. There's only 4 fractions to set up. Let's go ahead and set all of them up. Remember, your formula is chi-squared equals the sum of observed minus expected squared divided by expected. Okay, so I want you to set up your work, get your chi-squared statistic p-value, and make your conclusion come on back when you're finished. All right, let's see how you did. So I have my 4 fractions set up. If there was a whole bunch more, I would have just done like 2 plus ... plus the last one. Once this is all put into the calculator, I got a chi-squared statistic of 18.75. So that means 18.75 standard deviations away. Okay, so that's pretty far. And we got a p-value. It should have shown up in scientific notation. This is what the actual p-value is, 0.000015. It was like 0.149 or so. Okay, so it's a very tiny probability. I drew my chi-squared, I shaded it, I said there's a degree of freedom, because remember, it's row minus 1 times column minus 1, so it was 1 times 1. All right. Now for our conclusion. Assuming that taco tongue and evil eyebrow are not associated for all seniors is true, so this is just the null statement, and then I put is true after it. There is a 0.000015 probability of getting a chi-squared of 18.75 or greater purely by chance. Because our p-value is less than 0.05, we're going to reject the null. We do have convincing evidence of an association between taco tongue and evil eyebrow for all seniors. We rejected the null, which means we have to have the follow-up analysis. And so that's where these numbers come in. 2.5 is this value for this fraction. 1.25 is the value for this fraction. The largest component of chi-squared was no taco tongues, yes, evil eyebrow. It was lower than expected. Okay, and so how do I know that? Is I went back up here and I saw that one's lower than expected. This one's higher than expected. This is lower than expected, and this one is higher than expected. But if you look at them, all of these are 20 apart. These are 20 apart, these are 20 apart, these are 20 apart, and these are 20 apart. However, if you're 20 apart in a bigger number, when you divide by this expected value, it doesn't create as much of a, it gives you an idea of the scale, but when you have small numbers and they're 20 apart, that's starting to have more of an impact, okay? So it had, by far had the largest component of our chi-squared statistic, and so you just want to call it out and explain what happened. All right, so let's flip this over and summarize what I want to be sure you take away from this lesson. All right, the first thing that I want to remind you of is how to write the hypotheses. For the chi-squared test for independence, your null hypothesis is there is not an association. Okay, so there is no association between your two variables. So I'll just write in here, this is variable 1, and that one's variable 2. Okay, and your question will draw out the variables that you'll be filling that in with. Your alternative here is that there is an association between your two variables. Okay, we got variable 1 and variable 2. All right, so that's for your independence and association. We've used those a lot together throughout the course. They mean they're looking for is there a relationship. Now, how do you know which chi-squared test to use in a situation? Okay, so our chi-squared, the three we've talked about, chi-squared goodness of fit. So your chi-squared goodness of fit is going to have one sample with only one variable. Okay, our homogeneity okay, that's going to be 2 or more samples, but will only be one variable. So kind of think about the variables of what is being asked. What's your favorite color? And they could say 18 different colors, but it's one variable that's asked about. If they ask a question, 2 questions, what about this and this? That's 2 variables. Those are 2 different things. Can you taco tongue? Can you evil eyebrow? Okay, and so that's 2 different things that are going on. So that's kind of when we're looking for our independence there. So chi-squared for independence is you only have one sample, but you looked at 2 variables for that one sample. Okay, so in our unit, the independence, that was our taco tongue / evil eyebrow. It was one sample of 600 students, but we asked them, can you taco tongue and can you evil eyebrow? Then we had the question about the gummy bears as the color distribution. Okay, so in the gummy bears, it was 2 different samples, one from Meyer, one from Haribo. And then the variable was, what's your color distribution? Okay, there's multiple colors, but we're trying to find out what the distribution is. And then for goodness of fit, we did the does Harvard discriminate? We had one sample, it was the class of 2019, and we had one variable, and that was their admittance rate. Okay, so hopefully I'm kind of associating the activity with which kind of chi-squared will help you with this. So what I want you to do is try to check your understanding. So it says, for each situation, decide what type of chi-squared test is appropriate and explain. The explain is perfectly fine if you tell me how many samples and how many variables, and then tell me the kind of test. That's what you're really trying to pull out of these, so you're able to identify which kind of test you want to run, and then check your answers on Canvas. Let me know if you have any questions. See you in class.